Okay, so today we're going to talk about work at constant pressure. And so what we're looking at here is the two ways that something can work out. So you've got a gas at constant pressure, and so what's happening is the gas particles inside are going to start to push on a cylinder. Now if those gas particles are able to push the cylinder upwards, you're going to have expansion. And so what's happening is the system, having expanded, is doing work to push that cylinder away. On the other case, if you have a cylinder moving downwards into the system, now you have a case where the outside is doing work to push the cylinder into the system. So really it's going to be a matter of perspective. And so essentially what happens is if the volume is increasing, so if this delta V term is going up, then you have work being done by the system. But work done by the system should be negative. So we have to change the sign for this overall product. Whereas if the volume is decreasing, that would be a negative for the delta V, in which case then we need to change that because when work is being done on the system, that's a positive. Alright, so you can kind of follow the arrows to see which way the cylinder is sliding. So we've got two questions here. Question 1, if a cylinder expands from 3 liters to 5 liters at constant pressure of 3 atmospheres, how much work is done in joules? So for this case, because we're being asked about work and we've been given a constant pressure as an indicator, we know that work is going to be equal to negative P delta V. So as far as our values are concerned, we know that work is going to be equal to negative 3 times, and then we have to take a look here. So it's expanding from 3 liters to 5 liters, and so I'll write this up here. So delta V is going to be equal to volume final minus volume initial, which means we're going to be going with 5 minus 3. 5 minus 3 is a change of 2 liters. So this is 3 atmospheres and this is 2 liters. And so when we look at this, we're going to have negative 6, what's known as liter atmospheres. Now, it just so happens that there are 101.3, so to make our conversion, we now need to go from the 6 liter atmospheres that we have into joules. And so we're at negative 6 liter atmospheres. For every 1 liter atmosphere, there are 101.3 joules. And so we're looking at 6 times 101.3, which puts us at 607.8 joules. And that's a negative 607.8 joules. Now the other question that we have was if a cylinder is compressed from 8 liters to 4 liters at a constant pressure of 2 atmospheres, how much work is done? Remember that this sign is important because right now that negative sign indicates that the system is doing the work. Okay, so let's pull out the old eraser, get rid of all this. And start with that new problem where now we have a system that is being compressed. And so again, we've got work is equal to negative P delta V, and so work in this case is going to be negative 2 times, and now we're looking at it's going from 8 liters to 4 liters, which means the final state is 4 liters, the initial state is 8 liters, so we're looking at a negative 4 liters, and this is again atmospheres, so work is going to be equal to a positive 8 liter atmospheres. And because the question was left as how much work is done, no specifics as far as the unit requirement, liter atmospheres will work just fine. So those are the main concepts here. So if a system is going to be expanding at a constant pressure, the system's doing the work, you should have a negative sign for your resulting work value, and if you need to make a conversion, 1 liter atmosphere is equal to 101.3 joules. Now, if you have a system that's being compressed at a constant pressure, now work is being done on the system. And so, hope this helps out. Another idea here is, in order to maintain the constant pressure, the number of particles is going to have to go up. And so, if we're looking at this, we can't necessarily have a starting value of, say, 10 particles here and 10 particles at the end to maintain constant pressure. We're going to have more particles at the end than we did at the beginning to maintain the same pressure as we had here with a bigger volume. Same way, if we're going to be decreasing the volume, then we're going to have to go through and do a little bit of removal of some particles, because with the lesser volume, to maintain the same pressure, we need to have less particles. So you can look through at a reaction equation and maybe be able to make a prediction about whether or not at constant pressure work will be done by the system or on the system. So again, hope this helps. Good luck putting it to use for yourselves.